Presentation on OpenMP directives for parallel programming. Today, we'll be discussing two important directives, first private and last private. These directives are essential for optimizing your parallel code and achieving maximum performance. So, first of all, what is first private? First private directive is used to initialize variables before entering a parallel region. The directive ensures that each thread has its own copy of the variable, initialized with the same value as the original variable. This is important for avoiding race conditions and maintaining data consistency. Here, we have an example of showcasing how to use first private. So here we've got this code that's like a team leader handing out tasks to a team. Every team member gets a task labeled X, and initially X is set to 44. Now, when we say pragma OMP parallel for private X, we're telling each team member to start their own version of task X. They each get a fresh start, so they don't mess up each other's work. But here's the twist. Even though they're all doing the same task, they don't know it started at 44. So we use first private, give them a heads up. Hey everyone, your task TX should start at 44. As they do their task, they each show how far they've gotten, which is what we see in the output here in the next slide. Each line is a team member showing their progress. In the end, after everyone's done, we check the original task X and it's still at 44, just like we said it in the beginning. This is because first private made sure everyone started right, but they worked independently. So first private is a way to make sure everyone on the team starts off on the same foot with task X. It's like a synchronized start in a race. Everyone begins together, but they run. Now, what are some of the benefits of first private? We have improved performance by reducing race condition and data inconsistency. Easier debugging by isolating variables to specific threads, and increased flexibility in parallelizing code. Next, we have the last private directive, which is used to ensure that the value of a variable is preserved after exiting a parallel region. This directive ensures that the final value of the variable is copied back to the original variable after all threads have finished executing. This is important for maintaining data consistency and ensuring that the correct results are returned. So here in the next slide, we have this code. We start with the variable named var and set its value to 100. Then we tell our program, hey, let's do 4 tasks at once, and for each task, use a copy of var. The last private clause is our special instruction that says, after all tasks are done, the last one to finish, give its copy to var back, of var back to the original var. So as the program runs, each task is updating var with the task number. They're all working with their own copy, not affecting each other. When we finish all the tasks, we look at var again. Even though it started at 100, it now has the value from the last task that finished, which in our output shows as 3. So the last private is like a relay race, where the last runner passes the baton back to the first one. It's a way of final we did. So now let's see some of the benefits of last private directive. It helps improve accuracy by ensuring that the final value of a variable is preserved, easier debugging by isolating variables to specific threads, and increased flexibility in parallelizing the code. In conclusion, the first private and last private directives are essential for optimizing your parallel code and achieving maximum performance. By using these directives, you can reduce race conditions, maintain data consistency, and ensure accurate results. Thank you all for listening to this presentation.